study that we discussed about. Okay. So what is cyber? Primarily, it's with it's also double stranded. So it's a dye that goes and binds with double stranded DNA, and when you shine a specific wavelength, it starts first. Okay. Basically means if you have more amount of starting DNA at every amplification cycle when there is a double strand DNA formation, more and more cycle will bind. And then cycle signal will go off when you reach 90 because now DNA has become single stranded. All the cycle falls off. Now again 60 degrees Celsius when there is again an extension is you cycle again goes bind for the double stranded DNA. Again you put strong laser light on your tube. There is fluorescence and a measure how much of DNA is being produced. So if you repeat this at the end of each cycle, cycle 1, 2, 3, 4, 5, what will your instrument record? Your instrument will record the increase in fluorescence after each cycle, and then assume that this increase in fluorescence is due to increase in the amount of double stranded DNA present in the tube. Right? So that's what I written here. That fluorescence intensity correlates to the amount of DNA produced. Why is it advantageous? Because of all the data and PCRs that you using cyber or pro-based cyber whatever ideas you get already can be of the past when it's very only one type, you don't need to use multiple tools. So the instrument that you use it can be very cheap. Now if you have a PCR machine that can work for attack microscope, they need lasers, and X, sci-fi. For each fluorescent dye, you need a different excitation, and each excitation means a new laser block. Each laser block means 5 लाख रुपया महंगा होगा, उसकी कीमत 1 लाख रुपये और मिलेगी। combined with all kinds of product strategy, including non-specific products and primer. So when you design a primer that you are using for sample chemistry, make sure it does not use any non-specific product. There are tools that you can use to make sure. I personally like primer blast from NCBI. It's a very good tool because you can put a specific, suppose you are trying to track remember, not only have to check for, so basically you are taking a infected tissue from a human and then you need to check for viral load. And suppose the primer that you have made for your virus by a fluke chance also amplifies part of the human genome. It happens due to homology or that were not infected. Because you are saying something that is non-specific. So that part, that is part of my lecture is always verify before you jump into the verify it, it's a quantitative, look at the DNA pattern. If possible, now this is treated as a standard sequencing. Initial product, try to do because I'm telling you from my personal experience. Sometimes I was working on the thing called receptor, follicle stimulating hormone receptor. I was very happy with my assay until I sequenced my product. My product, in last search, showed homology both with luteinizing hormone receptor as well as follicle stimulating receptor. You see, primarily through the G protein and my primers and the transmembrane domain. Transmembrane domain is actually saying, oh, I should have taken either the ligand binding domain or the single domain. But somehow I was very, at that point of time, it did not occur to me. Right? So designing a primer very thoughtfully will cut down a lot of work when it comes to optimizing your assay for yields and PCR. So first design a primer, check it out in silico, and this checking the boxes. Another one is like exon junction. Whenever you design a primer for yield and PCR, try to make sure that it stands an exon junction. What is the exon junction? But primarily, to know the basic structure, we carry out a gene exon 1, exon 2, exon 3, then you have introns, right? So this is the basic structure. You have exon, you have intron, then you have exon, then you have intron. When I'm meaning exon junction, that means I'm talking about the post mRNA where E1, E2, and E3 are lying side by side. Fine. When I'm talking about those for the exon junction, I'm talking of a primer that binds here or here. Now, if my primer is binding here, tell me, will this primer bind? So basically, half of the primer is here, half of the primer is here, half of the primer is casting out. लेकिन मुझे फायदा क्या होगा इससे मेरे प्राइमर सिर्फ exon जाके बाउंड्री में जाके फाइंड करे what can I effectively rule out exactly there even if there is some genome DNA contamination very unlikely that genome DNA will be amplified. If I design a primer that binds to exon 1 completely and exon 2 in between, तो इसको तो यहाँ पे भी binding site देगा, यहाँ पे binding site देगा, होगा क्या? आप आपके पास will lie in the cleavage, 2 kb. Another will lie in the 100 base pair or 200 base pair. 200 base pair is the RNA. The 2 kb one was actually the intron also got amplified. So what will happen is the cytogreen we will get tremendous high intensity after the assay when you have a subsidized, but then you will realize you became an ass. The assay became assay just made you an ass. Right? So always make sure that your primers, and this is true for anything. आपके पास information है, go to NCI, go to primary space. There is a specific area where you can do all these footprints. And make sure that all your span is conjunction. Even if there is contamination, how do you know? Then you do the melt curve analysis. So this is again optimizing for cytogreen and lower specificity, which we have already discussed. And there is thousands of sectors. First, PCR product bank in anyone. Then, when PCR product color भी बन गया, in case of TACMAN, will it ever go and bind with the genomic DNA? No, it won't. It will go and bind only with the similar product. And lower specificity. So cytogreen has some issues. So it might give you false positives. False positive means आपको देख के लगेगा आपका DNA सिग्नल अच्छा है, your PCR curves are fine. When you go deeper into it, you realize all you are seeing is hallucinations and hallucinations. One more to protect you from this. Most companies have another type called a reference tag. That is ROS. That is carboxyx-rhodamine, and it's a passive reference tag. Why is it called passive? Because it does not participate in the amplification and it gives a stable signal. Right? So a passive reference tag is something that will not participate in the signal. That means the ROX signal will not increase per second. Because it's not participating. ROX का जो signal है, right from cycle 50 or cycle 100, whatever we are saying, ROX should remain stable. And why is this used? It is used to normalize the signal. This is something that is electronics and optics. That since we are getting multiple signals, one signal is continuously improved, you need to draw a baseline. What is my normal signal? What does ROS do? It is for pivoting errors, evaporation, and instrument variability. When you are setting up a 96 plate and you are doing it all low probability, every pipetting test that you will do will give a multiple depends on your right? Or how he or she handled the pipette, right? Or how he or she handled the pipette. Maybe using assistant and then asked to do that. So you would introduce a lot of errors in the pipette. ROX kinds of guides for it. Evaporation is one problem. Although there is a heated plate, but then with multiple scans, थोड़ा evaporation हो जाता है. People who have done PCR would appreciate the fact to take up the tubes, there is slight evaporation on the edges. So Okay, let me put it like this. Suppose I want to do shampoo or Adivasi तेल वाला ऐड देखा है ना? They want to use shampoo. किसको ज़्यादा shampoo लगेगा? आदिवासी तेल है. They are wrong. Okay. But if you see 21.2 will contain more of oxide. 17.8 will contain less of oxide. The signal will definitely be less for 17.8 compared to 21.2. But the computer has been told मैंने इसमें 20 डाला है. The computer now knows नहीं उसको लगता है कि 20 डाला है. Computer just by measuring the amount of rocks signal in each tube will connect for this pipetting variability. That saves you. So it ensures more accurate and reliable quantification because now it will normalize the fluorescence. Right? Now it will normalize the fluorescence signal generated by cybergreen. Okay, ये बंदा cybergreen का signal generate कर रहा है 178. This is also generating a fluorescence signal of 212.
Students might be interested to know whether is there need to use housekeeping this right now.
No, no. We'll complete. We have not entered G. We are still in the technique. So rocks and will emit a constant percent signal, and the instrument will compare the magnification and the stable signal of rocks, and it will reduce what we know as the noise data. Right? So what does it do? So it increases your precision. In instrumentation there are multiple words. One is accuracy, another is precision. So precision will be increased because it then you will come on the melting curve. So this melting curve shows there is only one product. Not all instruments support melting analysis. It's one big problem. But usually all modern instruments have this melting curve analysis. So if your instrument does not have melting curve analysis, very fine. Run your product on a 9 shell. Visualize it in the shell and see if there is any other bands. If it has a melting curve analysis, after you complete your PCR, add a HRM component to your PCR program. This is very important. Suppose you are working on gene expression pattern and for TACMAN, as I told you, just go through it. So there is a driver, there is a fluorophore and quench. Usually fluorophore and quench are very close to each other, so there is no signal. Once the fluorophore quencher are broken apart, you have signal. There are multiple kinds of light that do in this place. Analysis was primarily for cybergreen. So आप देखिए इतने सारे डाई हैं, इतने सारे excitation and emission है. There are primary quenchers, there are alternative quenchers. All these things mean more money. Both at the instrumentation level as well as the pro making. Lab, congratulations. You don't have to use cybergreen. It takes a lot of time to standardize stuff. You can just use fan X or Sci-5 combination. The instrument should support those. It should have all those features. It will make the instrument a bit more costly, but you don't have to do a lot of standardization. So there are two components. One is the thermocycle, another is the optical module. So in some instrument you can actually see that the optical module is different. There are specificities regarding the types of tubes you can use. Whenever instrument, whichever instrument you are using, make sure molecules match. Again, दूध का जला हुआ. So you order a lot of consumables and then you realize that your instrument does not take a flat cap tube. It will only take a dome cap. So if you are using a central facility, if you are using somebody else's lab facility, or even if you are using your own facility, when you just purchased a new PCR, talk with the engineer. He will tell you what are the exact component numbers, part numbers of the tubes that you need to purchase, what kind of optical clarity they need. So I am not going to the details of these things. Marketing वाले आपको ज़्यादा अच्छे से समझाएंगे जो सामान बेचना. So, but primarily you have these 96 format, there are tubes format, there are 8 tubes type format, 12 tubes का strip आता है. Depending on the number of samples you are handling every day. Like for COVID-19, we use these 96 because every day you are doing 2,000 to 3,000 samples, all manually. But if I am doing PhD, I was using strips of 8 because तब मेरे samples कौन थे? जहाँ ग्रुप है, replicate, 12 multiplied by 36, will know the print number. So even a 96 cell plate won't be filled. So use those tubes. Now we were saying there's one more aspect of quantification. Once you are done with the technical aspect of primer designing and assay designing, one more aspect comes like quantification and normalization. So once you know this is my target gene, you study. It's not easy just to take your target gene and press it, right? So first, and that is we assume that every cycle there is a doubling of product. Next, we do not need to know the exact DNA, but since relative quantification, we just need to know the relative quantities, right? But that brings us to the third basic principle. You have taken we varied just cancer and control issues. Now you have taken 1 microliter of RNA or CD but in reality you have put 0.8 and 1.3. That's the reality. All our pipettes are prone to errors. Our handling of pipettes keeps on changing. If you are angry, your pipetting will be different. If you are happy, then also it will be very different. Same person. So how do you normalize that? Then you need someone who should just like somebody who should act like rocks. But since it's a gene, it will participate. So rocks के साथ क्या था? It was not participating